Greetings everyone. So today we are going to discuss about a new topic which is the group 6A elements. In group 6A elements basically we have got the carbon, sorry, we have got group 6 elements also known as the oxygen family. Oxygen family. Now basically there is the first element oxygen, sulfur, selenium, tellurium and polonium. Oxygen, sulfur, selenium, tellurium, all of these are non-metals. This is a metal and a radioactive metal. Radioactive metal. And that is basically having the trend of metallicity increasing downwards and the trend of atomic size increasing downwards. And they have also the property of forming polyatomic linkages. Polyatomic linkages. For example, when we talk about their allotropes are polyatomic, which means they have more than one atom in the molecule. For example, oxygen has more than one atom, oxygen O2 and O3. Sulfur has more atoms, sulfur S2. Selenium likewise has more atoms. So they have polyatomic linkages. And they have the property of catenation. What is meant by catenation? Catenation is a self-linkage properties, which means for if we are having, let's say, 5 carbon atoms, these 5 carbon atoms have the capability to bind with each other. They have the capability to create bonds with each other. Hence, this self-linkage property is known as catenation. They are also having oxygen is also having catenation property, and the trend of catenation is decreasing downwards, decreasing down. Catenation, trend of catenation decreases downwards from oxygen to polonium. And another important thing is electronegativity. Electronegativity also decreases downwards, and oxygen is the most electronegative atom, second most electronegative atom in the entire periodic table after fluorine. Its electronegativity is 3.5. And these are certain general properties about the oxygen family or the group 6A elements. Now let's just understand a few more important things regarding the chemical nature. If you just look at the structure of oxygen, if you just look at all of these, their oxidation states, oxygen is having oxidation state of -2, and other elements such as selenium, tellurium, polonium, sulfur are having an oxidation state of -2, but also having oxidation state of +2, +4 and +6. While oxygen is having the oxidation state of +2, -1/2 and -1. So these are some oxidation states. By the way, the states which I have mentioned over here, these states, all of them are found in unstable forms. When oxygen is in an unstable state, then these oxidation states can be found. But naturally, these are the states. This is the state which is naturally found, which is -2. And selenium, tellurium, polonium, sulfur are having these states which are naturally found. Because why is that the case? Because oxygen family is having 6 valence electrons in its outermost shell. 6 valence electrons in its outermost shell. What does that mean? It means that it needs 2 more electrons to complete its outermost shell, due to which 2 more electrons in its p orbital would make the entire shell completed. So question arises that how does selenium, tellurium, polonium, sulfur form valency of +2, +4, +6? For example, if we take example of sulfur, sulfur can form bond with chlorine. It can form SCl2. It can form SCl4. It can form SEL6. If we talk about SCl2, in this case, the two orbitals basically Sulfur has its valence electrons as this: 4s2, 4p4. Now if you are going to break it down, the distribution of valence electron is like this: 4px, 4py, 4pz. These are the orbitals, right? So I'm just going to fill it according to Hund's rule: one electron in all of these and one electron over here. So there are two electrons, right? But what if I donate both of these electrons? I give both of these electrons. Then at that point, when both of these electrons are given, it can empty both of these orbitals, and thus it can gain a +2 charge. Second condition is when, for example, let's take the second atom. Now, in second case, for example, this is 4s, right? And then we are going to have 4px, 4pz, 4py, 4pz. Let me erase it. Yes, 4p, 4pz, right? So one electron here, one electron here. Now what I actually do is I excite it. If I excite it, then one of the electrons will go in the d orbital. Let's say it is dxy orbital. 4 dxy, 3 dxy orbital. In this orbital, I'm going to transfer this electron. This electron, which is present in px, would go here, right? In that way, I have got four valencies now. This is unpaired, this is unpaired, this is unpaired, this is unpaired. So four more electrons can be given in order to complete its valency, and in that way +4 oxidation state can be achieved. Third case is when I take electrons from the s orbital and transfer it to another d orbital. So let me just explain that as well. 3dxy, oops, 3dxy, 3dxz, for example. So this is having one orbital, this is having one electron, and what I actually do is I excite it further. When I excite it further, I transfer this electron from s orbital to another vacant d orbital, due to which it has now got 6 unpaired electrons, which can be transferred to the other atom, due to which a +6 oxidation state can be achieved. So this is basically all about it. Now let's understand a few more things, which is about its similarity with similarity between oops similarity between carbon similarity between oxygen and sulfur. So, oops, what's wrong? All right. So basically, we are going to understand the differences. We need to understand the differences between carbon and not carbon, but actually oxygen and sulfur. Oxygen and sulfur. Sulfur. Oxygen is gas at ordinary temperature. Oxygen has gas at ordinary temperature, and sulfur is solid at ordinary temperature. By the way, all of the 6A elements are having allotropic forms. Oxygen has two allotropic forms, and sulfur has three allotropic forms. Oxygen has O2 and O3, ozone, and sulfur has alpha, beta, gamma. Alpha is rhombic sulfur, beta is monoclinic sulfur, and gamma is plastic sulfur. And likewise, selenium is also having its allotropic forms, which is white and which is red and gray selenium. Tellurium is having metallic and non-metallic allotropes as well. Polonium is also having it. All right, it does not react with water, but sulfur reacts with water. Reacts with water. It basically forms hydrogen sulfide and sulfur dioxide gas, and it does not react with acid and alkali. It does not react with acid and alkali, but it does react with acid. Concentrated acid reacts with concentrated acid such as sulfuric acid or nitric acid, and it can react with alkali to produce thiosulfate or sulfide. To produce thiosulfate and sulfide, and then it is basically it helps in combustion, but it is itself not combustible. But this is combustible, and oxygen oxygen is oxygen cannot oxygen can sparingly dissolve in water, slightly dissolve in water, but sulfur is totally insoluble in water. These are a few differences. Now let's just move on to contact process. It was given by a scientist named as a German scientist named as Kinest. It contact process is a process to make sulfuric acid. It was given by first given by German scientist known as Kinest in the early 14 and 15th centuries when it was commercially produced in Europe. And it was first, discovered by sulfuric acid was first discovered by Jabir bin Hayyan in 8th century, and it is also known as oil of vitriol or the commercial uh, chemical of it's necessary for an economy of a country. So let's just understand the contract process. Contract process is pretty simple. So contract process is pretty simple. What we actually do is we basically first, take um, take sulfur or we first take sulfur or iron pyrite in a burning furnace or in a sulfur burner in which we burn it at a very high temperature at which we burn it at a very high temperature we burn it at a very high temperature to produce sulfur dioxide gas which is impure, and that impure sulfur dioxide gas then goes into the purity chambers. Purity chamber number one is the dust remover in which the water in which steam is injected into the sulfur dioxide to remove the impurities. Number two chamber is cooling pipe in which the lead cooling pipes are in which the sulfur dioxide gas is passed at 100 centigrade sorry at 100 centigrade in order to cool them. And after that we have the scrubber where we sprinkle water on sulfur dioxide, due to which sulfur dioxide being insoluble in water is unable to dissolve in water, but the dust particles are able to dissolve in it, due to which sulfur dioxide is purified. After that we have the dryer room in which what we actually do is a dry chamber in which there is dehydrating agent sulfuric acid which basically trickles down through the cork in the chamber, which is then utilized to dehydrate or absorb water from the sulfur dioxide. And then we have arsenic chamber. Arsenic chamber basically is specifically designed for eliminating arsenic oxide out of the sulfur dioxide. That is done with the help of ferric hydroxide, freshly prepared ferric hydroxide in the chambers of arsenic, in the shells of arsenic chamber, which basically purify the sulfur dioxide from arsenic oxide. And then we have another chamber named as the testing box, in which a beam of light is passed through the sulfur dioxide to identify any solid particles. If any solid particle is identified, then at that point, the sulfur dioxide is then again purified through the same procedure, otherwise, it is moved forward. After that, we have the contact chamber. Contact chamber is the process in which sulfur dioxide is provided is oxidized in the excess of oxygen. There is an excess of oxygen in the presence of a catalyst, vanadium pentoxide, at a very high temperature of around 400 to 500 centigrade. And another important thing to consider is it is an exothermic process which produces sulfur trioxide gas. Sulfur trioxide gas. And when the sulfur trioxide gas is formed, sulfur trioxide gas. And that sulfur trioxide gas is very important. That is then sent into the absorption chamber or the absorption unit. Absorption chamber or absorption unit. Within the absorption chamber or the absorption unit, the sulfur trioxide is absorbed into sulfuric acid, and the concentration of sulfuric acid is 98%. At that point, when it is absorbed into the sulfuric acid, it basically forms oleum or pyrosulfuric acid. Pyrosulfuric acid. Its formula is something like H4. Its formula is H2 S2O7. This is the formula for oleum or pyrosulfuric acid. And then the pyrosulfuric acid can water can be added into the oleum in order to dilute it and create sulfuric acid of our own concentration, required concentration. Now there are certain properties about the sulfuric acid. First and foremost, very important point, its melting point is 10.5 centigrade. Its freezing point is 10.5 centigrade. Its boiling point is 338 centigrade, and it is having a specific gravity of 1.8342 at 18 centigrade. And it can, when it mixes with water, it increases the temperature of water by 120 centigrade. And it is colorless. Pure sulfuric acid is colorless, a volatile, colorless, a fuming liquid, and it is highly corrosive. And it can react with water. If you are if you're going to put the entire bottle of sulfuric acid directly into water, then it can actually cause a blast or explosion. But in order to prevent that, we need to add it pretty slowly, in a thin line. So these are certain properties. Alongside that, we have some reactions of the sulfuric acid as well. It can act. It is a strong dehydrating agent. It is a strong dehydrating agent, such that as we have previously understood, that it can easily dehydrate stuff, as well as it can also, its cold dilute solution can its cold dilute solution can actually um, cause it can actually make metallic sulfates of certain metals such as iron, zinc, magnesium, and tin. While there are other metals as well which can have their which can make metallic sulfates with the help of hot sulfuric acid, which is copper, silver, and hydrogenium or mercury, while aurum and platinum do not react with sulfuric acid. And one more important thing is that the reaction with gases. Sulfuric acid can react with ammonia to produce ammonium sulfate, and can react with sulfur trioxide to produce oleum. And it can also react with benzene to produce sulfonic acid, and it can react with potassium permanganate oxide and potassium chromate to produce potassium sulfate, manganese sulfate, and potassium sulfate, manganese sulfate, potassium sulfate, sulfate and magnesium sulfate, alongside which there is the oxygen atoms produced, nascent oxygen produced, which can even cause the oxidation, sulfonation of iron atom, due to which it can even produce ferric sulfate. So when iron sulfate, potassium permanganate, and H2SO4 are mixed, they produce potassium sulfate, manganese sulfate, iron sulfate, potassium sulfate, magnesium sulfate, iron sulfate, and H2O. Alongside that, um, there it can also help in precipitation as well. For example, when barium chloride, lead nitrate, and barium chloride, lead nitrate, and titanium nitrate, barium chloride, lead nitrate, titanium nitrate are reacted with H2SO4, then at that point they create uh, white precipitates of barium sulfate, lead nitrate, titanium sulfate, lead sulfate. Yes. This is all about the video. Hopefully, we'll meet in another video.